Here are a couple of antiderivatives that are related to the arcsecant. Remember, the derivative with respect to x of the secant inverse, or the arcsecant, is 1 over the absolute value of x times the square root of x squared minus 1. So if you see this notation, it's saying, well, what function has this differential? And that would be the arcsecant of x, right? Or the secant inverse of x. Oh, plus c. Now, usually, or sometimes anyway, it comes up that you have something that looks an awful lot like the arcsecant, except for there's no absolute value. So we're wondering, are we stuck in that case? Well, the answer is no. There's a little trick we can use here. Let's check out this function, the arcsecant of the absolute value of x. If we take the derivative of that, we can actually think of it in two cases. So in the first case, assume that x is greater than 0. If x is greater than 0, when you're taking the derivative of the secant inverse of the absolute value of x, since if x is positive, the absolute value isn't doing anything, so you're just taking the derivative with respect to x of the secant inverse of plain old x, and we know that that is 1 over the absolute value of x times the square root of x squared minus 1. But if x is positive, the absolute value of x doesn't do anything, so that's just 1 over x times the square root of x squared minus 1. On the other hand, in our other case, so case 2, if x is less than 0, then when you're taking the derivative with respect to x of the arcsecant of the absolute value of x, then you're just taking the derivative with respect to x of the secant inverse of the opposite of x, because if x is negative, the absolute value of x is the opposite of that negative number. So negative x would actually be positive in this case. Of course, that we can apply the chain rule to. You would take 1 over the absolute value of the opposite of x times the square root of the opposite of x squared minus 1. However, since x is already negative, the opposite of x is positive, so the absolute value won't do anything to that. Oh, I forgot to multiply by the derivative. What's inside? The derivative of negative x with respect to x is negative 1, so I should have had a negative there. Okay, so let's see. We've got a negative up top. Now, the absolute value of the opposite of x, since x is already positive, the absolute value won't do anything. And if you take negative x times negative x, that's the same thing as x squared. So we have negative 1 over negative x. But you can cancel that negative top and bottom, and you have 1 over x times the square root of x squared minus 1. Doesn't matter which case, whether x is positive or negative, the derivative of the arcsecant of the absolute value of x turns out to be this value. So if you don't have the absolute values, you're not stuck. You could use this, the secant inverse of the absolute value of x plus c. The rest of the arc-trigonometric ones are pretty straightforward. If you look at this one, that looks like the arc sine. Since it's kx, I'm going to guess that that's the arc sine of kx. And if I check, let's see, the derivative of the arc sine would be 1 over the square root of 1 minus the inside function squared times the derivative of what's inside. What's inside would give me a k, so I just need a 1 over k there to cancel the k that comes out from using the chain rule. This looks like arctan, right? So if you do the arctan of kx, then the derivative of the arctan is 1 over 1 plus the inside squared times the derivative of the inside, which is k. So again, set a little trap with this 1 over k to catch that k. This one is 1 over k times the secant inverse of kx. And this one, where there aren't any absolute values, we just saw that that would be 1 over k times the secant inverse of the absolute value of kx plus c.